Welcome back. Now, till now we have discussed uniform bar, stepped bar as well as taper bar. Now we are moving to the last problem on this bar problem, that is thermal analysis problems. That means till now we have given only loads. So now because of load the structure going to be expand or contract. Not only that, even if you supply heat, the structure going to be expand. So therefore that kind of problem we are going to do whenever any member subject to a temperature. So what will happen? It's going to be deform. So that kind of problem we are going to solve today. That is one type problem. So that is this problem. This is a stepped bar along with the load is there with thermal conditions. So let me read this problem. Find the nodal displacement stress in each element and reaction at the fixed end. The figure shown in below. If the structure is subjected to an increase of temperature, delta T is 75 degree and P1 is 50 kiloton and P2 is 75 kiloton. So this is about the given stepped bar. 3 steps are there, each having different cross section. What is the cross section? So and also very carefully observe here, each made up of 3 different cross section along with the 3 different material. Therefore one is this one step 1, it is made up of bronze material, this is aluminum and steel. Therefore it is having different E values, as well as here one more property will come, that is known as thermal property, that is known as alpha, where alpha is nothing but quotient of thermal expansion. So that is different for different material. So all this they are given here. Now this is like a composite because it's made up of more than one material. Till now we have solved only we are not dealing with only common material, that is it is not a composite. Now this problem is including composite including thermal also. When the temperature is exposed to this power around 75, what may be the stress deformation as well as reaction, we need to find it. And this is what given the dimensions. This was section 1 is 800 mm, this is 600 mm and 100 mm, and both ends it is fixed. And also they given the area of different cross section. So let me execute in the Ansys. Let's move it into that. Now preference, let me select the now structural only, it is come to the structural only. Therefore now how many element we need to select? This is bar, there are 3 steps, therefore we need to select it 3 link. Therefore link 1 apply, link 2 apply and link 2. So 1 2 3 we got. How many real constant? 3. So let me carefully give the, let me select 1, give the area, that is it is made up of bronze material. So that is 2400 apply. Okay, now let me select the and let me select 2. Okay, so what is the second material? The aluminum is 1200, right? 1200. Okay, then third one, let me add, select 3, press OK. It is made up of real and it is 600. Press OK. Now we give the 3 real constraint. Now we need, next step is we need to create a material models. How many material models we need to create? 3 now. Till now it is 1 because it's made of a single material, but now it is 3 different. So that is very important. So let me close this and go to the material model and structural, linear, elastic and isotropic. So what is the Young's modulus? Everything we are converting in a now mm, right? Therefore 83 into e power 3 and 0.3. Press OK. Also, we need to give one more material property, that is thermal property, that is the coefficient of thermal expansion, that is second coefficient is isotropic, and that is 18.9 e power minus 6. Press OK. Fine. Now we need to give one more, right? Go to material and new model, ID number 2. Now for that we need to give isotropic on this exponent 70 into power 3 and 0.3 and quotient of the 23 into e power minus 6. Let me close to this. Now go to one more new material model, that is 3, that is 200 power 3 0.3 7 8 minus 6. Okay, so keep this in mind. We created 3 material model. Material model 1 means it is bronze, 2 means aluminum, and 3 means steel. Let me close this window. Like this. Now we are moving to the model. So create nodes. So now it is mounted on horizontal. Therefore, we need to give an x coordinate. This is 0. How many nodes? There are 4 nodes, correct? So node 1 is 0, node 3 is 800, comma 0, 0, node 3 is 800 plus 600, comma 0, 0, as well as fourth node is 800 plus 600 plus 100, comma 0, 0. So now let me give that one. Apply. Only apply that. Second node is the value 800, right? Now, so the first one is not created. 3 is 600 plus 800. Let me give like that only. 600 plus 800. Fourth one is 600 plus 800 plus 400. Now, we have to be very careful in the next step, that is creating a elements. Now we need to create a element attributes first. So link 1 means it is bronze. If the measurement is 1 and real constant is 1, press OK. Now you can go for auto number through node 1 to 2, press OK. Now element 2. So let me go to link 2, material model 2, and this one is also 2. Be careful. So next me go to through node 2 to 3, press OK. Let element 3. So let me set all the things 3. Through nodes 3 to 4, press OK. So now it is added in different columns. It is made up differently. So let me see whether steps are created or not. For that, what should I do? We need to go for here plot controls, style, size and shape. Let me switch on this, press OK. Then plot elements. Now let me keep this in isometric view. Then we got a 3 step. So now if we do like this, we can verify that again correctly the material, that is element attributes or not. Suppose this is looking the same area, means we are not given properly. Maybe you are not selected the element attributes. This is very important. So let me remove this again, keep this in front view, then Okay, now we are moving to the boundary condition. So for the solution, solve, define loads, apply structural displacement on nodes. So which are the nodes we need to fix it? First and last nodes. Let me select both at a time and press OK. Now fix it in all direction. Now we need to apply load. Let me force on nodes on second node. Press OK. So you have to check in the problem. So second node is P1, that is minus. Reverse to the expression. It is 50 kilonewton. Let me convert it to Newton. Next, let me use third node. Press OK. So that is again 75. So that means like this we completed the all the boundary conditions. Now it is and also one more very important is we need to apply temperature, right? So that is temperature on elements. So what is the temperature? 75, right? So let me take to the uniform temperature. Sorry, uniform temperature, that is 75 on elements. Pick all. Okay, now it is 3% completed. Let me solve this. Okay, let me view the results now one by one. General proposal, results, reaction solution. Press OK. Now we can verify with this at node 2 0.22 mm, node 3 is 0.01 minus. So mm, 0.22 mm. Yeah, e power 6. E power 6. Okay, this reaction, right? So I am checking some. So reaction is at the fixed is we can check here 227 and one is 102 kilonewton. So now you can observe here our result is we are converted in Newton. So not 2 Newton 80 power 6 is there, that is in terms of Newton. There given is in terms of kilonewton. Okay, correct. Next we need to see the this one, right? Element stress. For that we go for define the table first, then add, then okay, go to list results, element data, then the LS one, press OK. Now at element 1 94.7 megapascal or Newton per MSK. So correct. Element 2 is 145, correct. This one, so problem is right. Software is right. Now let me go to the nodal solution. So you have an X, or you can give this also. You better take to the X direction. Okay, so node 1 node 4 there is no displacement, only node 2 it is having this because so node 1 node 4 is fixed. Node 2 you can check 0.0, 0.22 and node 3 0 minus 0. Correct. So we are having the same result. So that means our problem is right. Let me see through the graphical contour plot results, contour plot, element table. Then press OK. So you can check now. This is a graphical representation. I hope you people are understood. So by this we completed the bar problems. Thank you.